In this video, we're going to address the slope of a line. As you probably would guess, the slope of a line represents its tilt. And in math, we use a number to represent the slope of a line. The way we calculate this number is by using a ratio of the vertical change between 2 points on the line to the horizontal change between 2 points on the line. The same 2 points, of course. And we give the vertical change and the horizontal change names. Commonly, the vertical change is called the rise, and the horizontal change we can refer to as the run. Now, rise and run can be positive or negative. So the rise is positive if you're moving up and negative if you're moving down. Run is positive if you're moving right, negative if you're moving left. And finally, we commonly use the variable, the letter m, to represent slope. And so if you consider that slope is the ratio of the rise to the run, the vertical change to the horizontal change, then we get sort of a formula for slope. And it is m, or slope, equals the rise divided by the run. We will commonly say rise over run. That's a very standard way to say that. But also rise per run is useful. Anytime you divide by something, that's per that unit. So this is more useful for like word problems or application problems. Okay, let's take a look at an example. So I have graphed a line and I need to calculate the slope of that line. Now recall what the slope is. It's a ratio of the vertical change between 2 points on the line to the horizontal change. So it's the rise over the run when you have 2 points. Now, there are lots of points on this line. Any point on the line would work. So we can pick 2. For example, I could maybe pick this guy down here because it seems pretty obvious what this point is. And then maybe pick another obvious point that intersects at a nice whole number coordinates, like this guy right here maybe. And then I need to calculate my vertical change and my horizontal change, or my rise and my run. So what you do is you pick one of the points and you travel to the other point vertically first and then horizontally. So if I start at the bottom point, I would travel up first and then right to get to that point. And I moved in this direction, so I'll indicate that here. The vertical distance is positive because it's up, and that is our rise. So in this case, the rise would be 1, 2, 3, 4, 5, 6 units. And the run is to the right, so that would also be positive, which is 1, 2, 3 units. So the run is 3 for this particular step. You could think of these as being steps. So I could say that m equals the rise divided by the run, 6 divided by 3, which is 2. Now, the 2 red points that I chose were completely arbitrary. Let's try different points. For example, I could choose this point and maybe this point. And again, I'm choosing really nice coordinates that are whole numbers, but sometimes that's not possible. So you may have to approximate decimals to calculate your slope. Anyway, let's take the same approach here. Instead of starting at the bottom point and going up to the top point, you could also start at the top point and go down to the bottom point. So if I were to do that, I would go down and left. So I'd be traveling this direction. And my vertical change, my rise then would be negative because I'm going down, and it's -2. My run would be negative because I'm going left, and that would be -1. So in that case, m would be the rise over the run, and it's still +2. So we can conclude something here. Conclusion, the slope ratio will always be the same regardless of which points you choose and which direction you move. Okay, so that seems pretty important. The slope of a line does not change. That's one useful property of a line, right? It has a consistent tilt, consistent slope. And we can see doing the calculation here that the steps, no matter how you make your steps between 2 points, they are always proportional. And when you look at ratios involving things that are proportional, the ratios always end up being equal. That's why the slope here is equal. Let's look at another example. In this example, I want to know the slope of a line. Now, I don't have a picture of the line, okay? But I do know 2 points that it passes through. So just a quick comment here. We could graph the line and determine the slope visually as before, okay? We could do that. But if we did that, it would be the same example as before. So let's take a different approach. But we try to calculate the rise and run without a picture. All right, so that's the goal of this problem. So I want to make that clear. So we need the rise and the run. And I'll remind you, rise is the vertical distance between the points. Run, let's do this, run is the horizontal distance between the points, okay? So if you think about in a coordinate plane and you want to measure a vertical distance, you measure vertically using the y coordinate. So if we want to calculate the rise, we will use the y coordinates, okay? Because y measures vertical distance. And for the horizontal distance, the run, we will use the x coordinates. So let's see what I mean by this exactly. I need to pick one of the points and travel to the other, just like I did in the picture, the graph that we looked at before. So if I were to take, if I start with -3, -6, and I travel to 5, -9, I need my rise and my run. To calculate my rise, I use my y values. So I'd be traveling from this y value of -6 to this y value of -9. Well, -9 is below -6, so my rise would be down 3, or -3. And then my run, if I travel from where x is -3 to where x is +5, that would be going from left to right. So that's the positive direction. So the run would be +8, because -3 and 5 are 8 units apart. So my slope here would be rise over run, which is -3/8. Now it doesn't matter which point I start with. If I reverse this order and start with 5, -9, and travel to -3, -6, then I do the same thing. So I would start with -9, and I would go up to -6, because -6 is higher than -9. So my rise would be +3. My run, I would start where x is 5 and travel to where x is -3, which is to the left. So my run would be -8. So using that, my slope would be +3 over -8. Now, a negative divided by a positive is a negative. A positive divided by a negative is also a negative. So both of these tell me that my slope is -3/8. And it happens to be the same, because it doesn't matter what order we go in. And we can see that in this particular case. Now, if you think you're going to have trouble remembering this, then just go back and graph the points in the line, and then calculate the slope by measuring your rise and your run visually. So just a comment here, the above example with the two ordered pairs, most textbooks present this formula here, y2 minus y1 over x2 minus x1. I personally choose not to emphasize that formula, because it looks, as soon as I give this to a student, they try to memorize it, and maybe forget it then if they try to memorize it. I personally like to use rise over run, because that's what a slope is by definition. So if you know that, you should be able to do a lot of problems on slope without having to memorize something new. But you're welcome to use that formula if you prefer it and understand it. Okay, so now we have our last example. Graph the line that passes through a point, 4, -6, and has a slope of -2/3. So the most obvious thing is start with this ordered pair, this point. So let's plot it. 4, -6 is right here. I'll highlight that because that's where we're starting from. And then I need my slope of -2/3. Now, -2/3, that ratio can be written lots of different ways. It could be -2 over +3, so our rise would be -2 and our run would be +3. Or it could be +2 over -3. Or it could be -4 over +6, or +4 over -6, or on forever. You can come up with all sorts of different ways to write that ratio. Okay? So what we need to do is, well, I've got a point, so let's use my rise and run to get other points on the line. For example, I could rise -2 and run 3. So if I rise -2, that means go down 2 and run 3. And I get another point right here. And I could repeat that. Rise -2 again and run 3. And I'll get another point. I could also, sorry about that, I could also, let's go back to the starting point, I could rise 4 and run -6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And I get a point right there. Let's put that in blue. Sorry, I forgot to draw the step. So rise 4, run -6. And then I could rise 2 and run -3. So rise 2 and run -3. And I get a point right here. You get the idea. You can use your slope from any point on the line to get another point on the line. And I'll try my best with my tablet here to connect these dots, these points, to get a semi-straight line. So this is the line that passes through 4, -6 and has a slope of -2/3. Now, just a comment here about what your slope could look like that might throw people off. If your slope is a whole number, like 5, think of it as a fraction so you can quickly identify your rise and run. So if you think of 5 as a fraction, there are lots of ways to do that. 5 is the same thing. The obvious one is 5 over 1. You could also use 10 over 2. You could also use -15 over -3, right? And you get the idea. There are lots of different ways to write 5 as a fraction. Any of those would be fine, and they would each give you different rises and runs. Okay, so that's what you do if your slope is a whole number. So hopefully you get the point. Slope is a ratio of the rise to the run, and it's consistent no matter which points you use or which direction you move on the line.